Now that we understand how to use our primary trig ratios, we can start applying that knowledge in word problems. And that's what we're looking at today. So to get started, we're going to take a look at a couple terms, angle of depression and angle of elevation, and what they mean. So the angle of depression is looking down at an object, and it's the angle that's created with the horizon, okay? And the angle of elevation is the angle looking up at an object, and it's created again with the horizon. So that would be this angle here. So let's see how we can apply that information in the questions. So the first question, we are told that a point 787 meters from the base of the CN tower, so that means that this must be 787 meters. It's telling us that the angle of elevation looking at the top, so we're down here and we're looking at the top of the CN tower, and it's telling us that the angle of elevation is 35 degrees. So that's this angle right here, so we can write that in as 35 degrees. Now we're asked to calculate the height of the CN tower, so this is what we want to know over here. Our next step whenever we're working with primary trig ratios is to label our right angled triangle. Because this is the angle that we're focused on, it makes this the opposite side, this is the adjacent, and across from the 90-degree angle is always the hypotenuse. Now let's take a look at what we know and what we're looking for. We're given information about the adjacent, and we're looking for the opposite. So now we need a trig ratio that relates adjacent and opposite together. And that trig ratio is tangent. We know that the tangent of theta is equal to opposite over adjacent. I can plug in information that I know. I do know what theta is, so I can plug that in, 35, equals opposite, which is x, and the adjacent, which is 787. Now I can cross multiply to isolate x, so basically I'm going to be moving the 787 up to the top on the left hand side. So we're going to get 787 times the tangent of 35, and that's going to equal x. And now all I need to do is pull out my calculator, and because I'm using a backward calculator, I have to start with 35 and then tan, and now I can multiply by 787. And the answer I'm going to get is 551.06. So now I know the height of the CN tower, given this information, is 551.1 meters tall. Let's take a look at the second question. In the second question, we're told that we have a building that is 104 meters tall. So I'm going to write that in right here. And it casts a shadow that is 156 meters long. We're being asked to calculate the angle of elevation of the sun. What we're actually asked for is what this angle is right here. If we are down at the bottom looking up at the sun, what is the angle of elevation? And I'll represent that by theta. The next step, as always, is to label our diagram. So, because this is the angle we're focused on, over here is the opposite. This is a 90-degree angle, so this is the hypotenuse, and that makes this side the adjacent. We know information about the opposite, and we know information about the adjacent. So to find theta, we're going to use the tangent ratio, and it's tan theta equals opposite over adjacent. We don't know what theta is, but we do know that the opposite is 104 and the adjacent is 156. Now, to find theta, we have to effectively move the tangent over to the other side, and it becomes tan inverse equals 104 over 56. Now I'm going to pull my calculator out and I'm going to calculate theta. So when I start entering this in, I have to start with the stuff that's in the brackets first. So it's going to be 104 divided by 156. I'm going to hit equals. Now I can go into my trig drop down, go second function and tangent, and I see that that angle must be 33.69 degrees. And I can round that to 33.7 degrees. Let's take a look at the next question. In this question we have a ladder that is 5 meters long. So I can write that right here, It's 5 meters long. This is a 90-degree angle. And we're told that the base of the ladder down here is 2 meters away from the wall. Now we're asked to determine the angle the ladder makes with the ground. So we're actually looking for this angle right here. When I label my triangle, I know that this is going to be the opposite because this is our focus angle. This is the adjacent side, this is the adjacent side, and across from the 90-degree angle is always the hypotenuse. I have information about the adjacent and I have information about hypotenuse, which means that I'm going to be using cosine of theta equals adjacent over hypotenuse. Plugging in what I know, cosine of theta is going to equal adjacent, which is 2, over hypotenuse, which is 5. So that means that theta has to equal cosine inverse of 2 over 5. Let's grab our calculators. Again, I have to start with what's in the brackets because this is a backwards calculator. So it's going to be 2 divided by 5 equals, and then trig, second function, and we're using cosine this time, so cosine inverse. And the angle must be 66.42, and we can round that off to 66.4 degrees. The second part of this question is asking us how far up the wall the ladder reaches. In other words, we're being asked for the opposite side. Now, because we've calculated theta and we know that theta is 66.4 degrees, I'm going to use that with either the adjacent or the hypotenuse to calculate the opposite side. So for this question, let's use the adjacent. So we're going to be looking for the opposite, and we know the adjacent. That means that we're going to use tan of theta, which equals opposite over adjacent. We can plug in what we know. We've calculated what theta is, so it's 66.4 degrees. The opposite is what we're looking for. I'll let that be represented by x, and the adjacent is 2. If I cross multiply to move the 2 up to the other side, we get 2 times the tangent of 66.4, and that's going to equal x. I'm just going to pull up my calculator. And again, because this is a backwards calculator, I have to start with 66.4. So 66.4, and then I'm going to hit the tan button, and then times 2. And that equals 4.577. So I can round that off to 4.6. So that means the ladder reaches up the wall 4.6 meters. Now, they want you to use a second strategy to check your work. Let's put what we know on here. So we know that this is 4.6, and we know that this is a right angle triangle. So that means that we can use our Pythagorean theorem to make sure that this works. The side opposite the 90-degree angle for the Pythagorean theorem is always C, and A and B are the other two sides. And we know that the Pythagorean theorem states that a squared plus b squared has to equal c squared. And if I plug in what I know, 4.6 squared plus 2 squared should equal 5 squared. Well, this side is easy, that's 25. And when I punch this in on my calculator, I get 25.16, which is pretty close. And because we did some rounding when we calculated theta and the opposite side, I think that this is a good answer. Time to move on to the next question. So let's take a look at what we have here. We have an airplane that is 450 meters high in the sky, and the angle of depression to the end of the runway is 32 degrees. We're asked for how far away the plane is from the runway along the ground. So in other words, we're asked for x down here. The angle of depression, plane is up here. The angle of depression is right here, so this is 32. But because these two lines are parallel, we can use our z pattern or alternate angles, and we know that this is 32 degrees as well. Now, if we label our diagram, we know that this is the opposite, and we know that this is the adjacent. Over here is the hypotenuse, but we're really not going to use that. That means that we're going to use tan of theta, which equals opposite over adjacent. Plugging in what we know, tan 32 equals opposite, which is 415, over adjacent, which is what we're asked to find. Now I'm going to move the x up to the left hand side and the tan 32 down to the bottom of the right hand side.
So that means that x is going to equal 415 in the numerator and the tangent of 32 in the denominator. Let's enter this in on our calculators and see what we get. So we're going to enter in 415 divided by 32 and then tangent and hit equals. We get an answer of 664.1. So that means the airplane is going to be 664 meters away from the end of the runway. So x is going to equal 664.1 meters. Let's move on to the next question.
In this question, from the top of a cliff, which is 106 meters above the water, so that means that this must be 106 meters, the angle of depression, we know that that has to be this angle, is 15 degrees looking at a boat out here. And we want to know how far the boat is from the base of the cliff. Again, this is parallel to this, so alternate angles says that this has to be 15 degrees. When we label our diagram, we know that this is the opposite, this is the hypotenuse, and this is the adjacent. Again, we're not really doing anything with the hypotenuse. We're using opposite and adjacent, so the trig ratio is tan of theta equals opposite over adjacent. Plugging in what we know, we get tan of 15 equals 106 over x. Moving the x up to that side and the tangent of 15 down to the bottom, so we end up getting x equals 106 divided by tan 15. All right, I'm going to pull up my calculator and let's see what we get. So I'm going to start with the top, 106 divided by, now I want to find out the tangent of 15, so I have to start with 15, then the drop down tangent, and now I can hit equals, and I can see that the distance must be 395.6 meters, and the boat is 395.6 meters away from the base of the cliff. Hope this video has helped. If you have any questions at all, you know where I am.